Today we're going to look at sinusoids. It's a second way of making a trig graph from real data. And what we'll look at are things like rides that spin. If you were riding on an amusement park ride, you would be moving in a circle, right? But if you think about it, you're also moving, let's say this is a fence. You're moving away from the fence, then you're coming toward the fence. You're moving away from the fence, you're moving toward the fence. And that is a trigonometric relationship. So what we're going to do is we're going to construct a graph from something like this. So here's what I'd like you to do. I would like you to go to this slide. This is on 14.2 where it says real sinusoids. And we're going to sketch a graph of what's happening. You're getting, let's say this is 0. You're getting close, far, close, far. It's just going to be a sinusoid graph, isn't it? We're going to figure out 3 pieces of data. This one, which is x close. This one up here is x far. We need to know those 2 pieces of data. And then all else we need is the time to make one cycle, or what we call the period. Okay? So I'm going to think of this ride. Here's a fence. This guy's 5 feet away. And this would be a number line. Here would be 0, where the guy is, 0, 5. How far is this one? If the radius is 12 feet, this is 5. What will this distance be? This is 0, 5. This will be how much? 17 feet. Good. What will this far be? Way out here. 20 what? If this is 12, what's this distance going to be? 12. So that'll be 29 feet. You okay with that? Is that good? All right. So then we're going to go A, B, C, and D. D is the middle. It's 5 plus 29 over 2, which is 34 over 2, which is 17. But what else is 17 on my picture? It's the middle, right? That's what we wanted, the middle. There's your D. So we have 17 for D. A is the next one we can do. Well, it's the high minus the middle. 29 minus 17. But that's a predictable number, too. That's equal to what? 12. That's the radius. So that's easy. Okay. For B, it's 2 pi over the period. So I'm going to make up a period to go around here. Let's say the period is equal to 2.4 seconds to make one rotation around. So you just go 2 pi over 2.4, which is going to be pi over 1.2, right? So that's it's a weird looking one, but 1 pi over 1.2. Now this is going to be your favorite one. We have 12 for A, pi over 1.2 for B, D is 17, C is going to be your favorite. Now when you start your clock, do you agree that you could start at any time this thing is going? Anytime, right? I'm going to choose to do the time when the distance, you guys will need to back up just a little bit. Not much, you almost have it. Is the time when it's the furthest away. That's going to be my peak. The reason I pick that is because I'm always going to choose C equal to 0. Okay? So we're always going to choose the easiest number we can imagine, which is C equal to 0. And there you have it. There is the sinusoid. 17 plus 12 cosine pi over 1.2 t. Let's do one more. Take your finger, hold it 1 inch from your nose. Don't touch your nose. Hold it 1 inch away. Does your nose itch right now? Don't itch it. And then go as far out as you can. Let's say it's 2 feet. I don't know if you can move your arm 2 feet, but okay, now bring it back to your nose. Now bring it out. Now bring it in. Okay, on your mark, get set, do what I do, go. 1, 2, 3, 4, 5, 6, 7. Don't hit yourself. 9, stop. Okay, that was 5 seconds. Okay, so we're going to write time period was 5 seconds to do 10, which is how much? 1/2, 0.5, right? 0.5 seconds. Good. The close is 1 inch. The far is 24 inches. We're going to make it up. And we're going to find A, B, C, D. So just to finish this example off, we found A or D by taking the average of 1 and 24, which is 12.5. Took the high minus the middle, 24 minus 12.5 to get 11.5. Period was 0.5 seconds, so we took pi over 0.5 to get pi over 0.25, and we chose C to be 0. And there's your sinusoid of your finger moving back and forth toward your nose.